Good morning, good evening, everyone. So basically, welcome again. This is very interesting week for us. I'm really hoping to learn a lot of things about like applications. So all things until now, we have been talking about database, how to create database, how to kind of work with the database, how to manage those database, and also a couple of kind of visualization aspects. I think moving forward with this lecture here, we will be learning about analysis of the data. So on that data that we are working with, if we are to start with a hypothesis and what tools we have, what kind of new tools that are available for us to use in analysis of those data. So I think that's going to be the focus today. And we are very fortunate here to have Samban Dal. So he is a PhD student with us. He has been here helping us with this project since beginning as well. So we're really lucky to have you here, Sam. And I think I'm very excited to learn new tools and techniques. So I think over to you, and we can, if we have any question, maybe feel free to stop him in the middle, as well as write your questions further in as well. We can continue the discussion at the end. Yeah.
So today my like the brief lecture or like discussion will about will be about introduction to machine learning. But the main focus of this will be to help you guys out with your projects. So I would like to go over the presentation as soon as possible. And then like I would like to have a more extensive session, like at least spend half an hour with both the teams and learn about the data sets they have so that like we can see on how we can go on to apply these machine learning techniques in practice. Because I giving you theoretical knowledge would not be of much help because just one session would be very difficult for you to like understand what essential tools you will be needing for your case. So let me start and let me just give you a brief introduction and a brief overview of how it is like machine learning. So this is just the introduction part. So the thing is like we have a lot of big data sets on which we go on to work in a daily life. For that, you require a lot of computational power. So that is why cloud technology is making a lot of advancement nowadays. Like every company is offering cloud services. Amazon Web Services is the leading example. You have Oracle Cloud, like which they use in NM AgriLife Center. Then you have Google Cloud Platform. So all of them are really nice. Like those are used to host machine learning algorithms because they are very computationally expensive. And like every day, the third point, like we are making a lot of progress when it comes to the algorithm aspect. So sometimes we go on to see that extra layer has been added to an existing machine learning algorithm. Some modifications have been made in layman term. That is what it means. So that we can go on to improve accuracy of the algorithm. So that goes on a daily basis, and a lot of papers come in uh, CVPR or IEEE regarding the improvement of the algorithms. So if you guys are interested, you can always go and search for those papers. They're really good. So there are many interesting applications. There are commercial applications, scientific application. In our case, we are dealing with scientific applications. In industry, it is mostly applied data analytics. Commercial applications, the existing machine learning algorithms which we have and how that can be used in handling large data sets. And one more thing, like AI is not equal to machine learning. So machine learning is just a small part of artificial intelligence. Artificial intelligence, the term is very broad. So we would not dive deep into it. So today we'll be focusing on machine learning. So first thing is supervised learning. So before going in depth into supervised learning, I would want to tell and interact with you guys. So you guys need to tell me on what your problem statement is. So do you guys have a label to work with that is in your data set? Do you know what to predict? If you do know what to predict, it comes under supervised learning. So I would like it to be more participative. If you guys like one from each of the team can go ahead and say what your data set is like, and do you guys know what you want to predict? or what you want to classify? Do you know the target variable, what your aim is at the end of the project? So anyone?
Yeah, I was meeting with one of the teams this morning. We had a good meeting this morning on the animal data we have. And basically on the animal side, like I can speak of that data because I work closely on that. And we can use, like we do have. So for this project, this is not like a research study, we did not start with a question. So we don't have particular research question in mind, but for particularly that data set, we can go either supervised or unsupervised way. So basically, if you want to predict, let's say, milk yield of cows, like how much milk a cow is producing based on, let's say, her number of steps, her how much time she lied down, how much time she ate, and all those kind of variables, that would be supervised learning. I think that's what
Yes.
I would
Exactly.
assume.
Yes.
But like, there are whole host of different variables. I think we had 28,000 data points and at least like 50 columns, 50 variables that we use. And if we are to use those to identify something within that data frame, not starting with, let's say, milk yield in mind, right? So we have different diseases. So are we able to predict diseases based on something else? I think that is unsupervised learning, I guess. But with
Yes.
that, I have another question for you, Sam. So basically, one thing that I'm an epidemiologist, like work with a lot of epidemiological data and analysis and stuff. So one thing they don't want us to start is something called fishing expedition. If you don't have a hypothesis in mind, if you start a project without any question, you don't have an objective in mind, you just go fishing and find out something. How well is that criticized? How is it handled on the machine learning side of it? I think that's what I always struggle on the unsupervised side.
So, so basically that would come under clustering algorithms. So you have so many data points. I'll be discussing about it in the later part of the slide. So you can just run some of the clustering algorithms on those data points and see how those data points would show up in clusters. So all the similar data points, like you can then find out the indexes of those data points, like observation 1, observation 15, observation 25, 35, all of them showed up in one cluster. And some like observation 2, 3, 8, all of them showed up in another cluster. And then suppose you have 10 clusters for these 30,000 data set, then you can further go ahead and analyze and find out the similarity between them, like handle each cluster individually, try to save those data, then try to find out the structure within that data, and you can proceed. So even without an objective in mind, you can definitely go ahead with these clustering algorithms that will definitely help you like for the purpose of research. I would rather say like research is very open-ended, but yes, sometimes like when we start up with nothing, like we do not have an objective in mind, sometimes we tend to get lost. I can completely relate with that. But yes, we can definitely go ahead and do that. So under supervised learning, it is like basically of two types. Regression is like predicting the exact numerical values, and classification is predicting the categorical values, that is labels. So like regarding what a regression and what classification is, I'll be showing it in the next slide. And under unsupervised learning, it is like clustering, which we just discussed, like grouping the data according to distance, like how they would show up in blobs or clusters, like the similar data points. And you will have like some kind of distance between these clusters to distinguish between them. And you can go out and find out the similarity or the differences between them. And another thing is data reduction, like how Dr. Sushil went on to mention, like his data set goes on to comprise of 50 different features. So definitely you cannot go on to use 50 different features in the data set when you go on to do any sort of regression or classification analysis. For that, you need to reduce the number of features. You need to reduce the size of the data set. the number of parameters which you will be using. So for that, you have a lot of data reduction techniques. So that all comes under unsupervised learning. Another thing is reinforcement learning. So under reinforcement learning, it is kind of like I did not knowingly did not put up any example because that comes under machine learning, but it is more or less like training an algorithm to accomplish a certain task. Like all these online games which you have, like which you go on to play with the computer or on the internet. Like initially they had a set of rules which were followed at least until 2015, 2016. But then reinforcement learning is kind of a branch of control systems where like they go on to prescribe a certain set of rules. They would take your move like and there and they would have certain moves and the computer would learn from the human on how to play a game. So generally they are used in all these online games where you go on to have this interaction between a person and a computer. So that is like nowadays turning out to be hugely successful. Initially, it was a failure. It is a very recent branch of machine learning which has come up, and it is quite difficult to understand. Like some of the algorithms, they are not that straightforward. But yes, definitely. Like there is a lot of research going on in this field, and everyone is like welcome to participate in this. So regression. So this is a classic regression problem. So there were a lot of black and white images before. So they are using this regression algorithm to go on to assign a color to this black and white image. So all this black and white image which you have of this butterfly, then of this jellyfish, of this mountain. So they did not have a color version of it. So they used this. You can go ahead with this link and you can go on to search in this. So this regression algorithm on this image was used to assign color, like it went on to assign color quite accurately to all of these images. So it was used to color these images. These were one of the initial applications of regression algorithms on images. And it is a classic example. It went on to do quite well. If you can go on to see. And this is a classification algorithm running on a image. So this is a picture of a dog and wearing a hat. So it is quite accurately able to predict the hat with a wide brim. This is the dog. So basically you can use it for object detection if you have a object, like if you can think of a bigger picture in mind, like you have a lot of vehicles on road, and then if you want to identify what type of vehicle is there on the road from a top view, then you can go ahead and do that if you train your algorithm with sufficient amount of images. So it is being done on a like nowadays on a like commercial basis also, like they are doing it, but yes, they always need improvement. But yes, work is going on this in this domain right now. So reinforcement learning, as I went on to mention, like online chess game is one of the best examples of reinforcement learning. They track the best moves from the players, then they go on to learn it by themselves, and you go on to have uh, then the computer goes on to detect the best move, which would be for a particular like for a particular move made by the player here. So this is kind of a clustering algorithm. So what this is a map of Delhi, so the capital of India, and this is the crimes this is the like crime records from the different part of the capital, and this is how they show up in cluster when you go on to like run these clustering algorithms. 1 2 3 4 5 6 7, so all these red data points, they show up as one cluster because the similar amount of like the similar nature of crimes are committed in these parts of the city. And this blue, like it is not visible currently, so you will have a lot of blue dots. They will show up as a different type of a crime which is being committed in the capital, and you have black dots similarly. They also go on to show up as another cluster. So basically the main purpose of clustering algorithms is to group the places, or like group the places according to the type of or the nature of the data. So what is the nature of the data that we going to have? The clustering algorithms would go on to group it by themselves. Like they would tell you like this the nature of data belonging to the number of data points belonging to this nature of data is these many, and this amount of and depending on the nature of the data, this is how it shows up in the other cluster. That is it. So some of the classic examples are k-means clustering, and you have hierarchical clustering, lot of clustering algorithms. It's good to start with k-means clustering, but then you can go ahead and search for other clustering algorithms. So these are some of the recent applications in science. You have like machine learning applications for Earth observation, machine learning for molecular and material science, applications of machine learning in biology, recent applications of machine learning in medicinal chemistry, and so on. So these are the machine learning algorithms which we go on to have. So these are the classic machine learning algorithms used for regression. So by regression, I mean like predicting a particular value. When you go on to predict a particular value in the output, like suppose you are predicting how much, like in the case of the animal data set, what is the yield of the cow? Like these many liters and milliliters, you are predicting a certain value. That makes it a regression problem. So for that, you have ridge regression, support vector machine, random forest. So these three are the machine learning algorithms which can be used. And multi-layer neural networks, deep neural networks, these are the deep learning algorithms. So although the purpose is alike, the structure is a bit different for machine learning and deep learning algorithms. So we'll not go deep into that, but for application purposes, you can go on to use these 5 to 6 variants of these algorithms for your analysis. And for classification, you can use the same support vector machine, random forest, multi-layer neural network, and deep neural network. So what do you mean by classification? Classification is like if I go on to classify the cows with a yield of more than 5 liters per week as one class, and less than 5 liters a week as another class. So here you are not predicting the actual yield of the cow. You are just classifying them into two classes. Like more than 5 liters is one class, less than 5 liter is another class. You can have multiple classes, but here you are not predicting exact value. So that is how we go on to proceed. Then by clustering, you have this k-means and hierarchical clustering, which I discussed before. So the main issue is like most of the machine learning algorithms like go on to in real time, they would go on to fail at around 85%. But then like work is currently going on to improve that. So reasons for failure: asking the wrong question, trying to solve the wrong problem, not having enough data, not having the right idea, like not having the right problem statement, having too much data, hiring the wrong people, using the wrong tools, not having the right model, not having the right yardstick. So among the frameworks, so the
Okay, can you
programming.
go back on one of those problems? So because I think that's what a lot of us like to start with, right? So basically,
Yes.
for those of us who don't have a background, we want to understand where not to make a mistake, right? So basically, I think all of this, what you are showing here is, okay, these are the places where a lot of people make mistake, and that's where models go wrong. That's where the prediction equations go wrong, and that's where the data, even though you have a data, the results are not accurate, right? So I think these are major problems. And okay, I think uh, I know I've been like asking questions on behalf of the students here a lot, but what what do you mean by, okay, enough data, right? So that's what I've been thinking myself as well. So how much is enough, right? So let's say going for a conventional statistics like the regular statistical tools versus big data tools or big data analytics, is there a demarcation? Is there a borderline? Okay, this is big data. This is enough data for us to go advanced tools versus something on that line. So what does that mean by enough data on that, and how much is too data? Too much data?
So having by enough data, you mean clean data.
Okay.
So sometimes like having too much data is having a lot of incomplete data, but then you have 30,000 observations, but from then you have 10,000 observations with incomplete data. You'll have NN, NN, NN everywhere, like no information.
Yeah.
So if you decide to use those 10,000 observations in your model while designing the model, that would go on to actually like make the predictions worse. Kind of like you are already taking 33% of the total observations, like you are trying to manipulate them so as to use them in your model, like fill them up with some value, or we use the mean, use the median, use the mode to do some kind of data imputation. That may not be the right approach. Sometimes it works very well, like because of the nature of the data. And a
Yeah.
lot of times that will result in big failure, like that will go to give you like disastrous results. So we have to decide on whether to keep those data points or we can do without. If we can
Yeah.
do without, that is the best approach. If you cannot do without, we have to look for other ways to keep those data and proceed.
And on the mathematical sense, what does it mean, like yardstick, like on the mathematical, the last bullet point you have, what does
Yeah, yeah.
that mean?
So not having the right yardstick, like sometimes what happens, like half of the data which will be recorded, like suppose we are recording rainfall. So this happens very regularly. So we go on to collect these data points from like different places. So half of them will be in inches, other half will be in millimeter. So we don't have a look at it. We combine the data and you will see like sometimes you will see 0.8, 0.8, 0.8, and suddenly you'll have 10, 12, 14. Then sometimes, and then like we as data scientists sometimes even do not question all this. Like we'll proceed with analysis. And then at a point of time, like sometimes when you meet with an agronomist, they'll say, oh, possibly they were recorded in inches and the other in millimeter. Then that
Yeah.
becomes like really bad at a point
Mm.
in time. So we have to make sure that everything is standard, like you have a standard for everything. Make sure that the units are right, they're uniform when the data
That-
is recorded.
That's
Like we record.
exactly, yeah. That's exactly one of the main reasons we had this workshop here, is to understand what it means, right? So for the computer science folks, or folks who have deeper understanding about these advanced tools and techniques, you don't know the background, what goes into bringing these data points, and for us, we don't know those tools. So I think we are trying to bridge this disconnect through a couple of the programs like this. But I think you are hitting the nail on the head. I think that's the major problem now is, yes, we don't know what goes inside the computer, all those algorithms side, and you don't know how those data were generated, and is it an outlier, or it's just a mistake, or it's a regular observation? I think that needs to be separated. But yeah, that's really one of the most important points out there. I really like it.
Yeah, so that is something also which we have to take care, because I have done this before. So I know rerunning the analysis in the end.
Mhm.
And sometimes when you cannot rerun the analysis, you go on to manipulate because you have to do something.
Yeah.
Oh, but that is disaster in the end.
Dr. Susil and Sam, I just wanted to, share something. Okay.
Yeah.
So, yeah, so actually, like this is a, a reality thing, like what we are right now discussing, because, sometimes the data collection is really, really hard. So as Sam also know, like, 2 weeks back, we went for the data collection in the cotton field, and it was my first time as a computer science person. I never been to the field, and I
Mm.
really went through a hard time. But that time I really like realized that the plant science guys, they are doing extremely good job, in that like outside with the higher temperature, those guys are really working hard to get those data things for us. So they are doing really fabulous job, very excellent job. But sometimes that data things, maybe we are thinking it is bad, or we are not getting the what we are expecting. But behind the scene, those guys are also working really hard to give us those datas. So probably we need to see a way, like whatever the data they're getting us, and we need to uh, try to replace it, or try to make it a kind of how we can make a stable data set out of it. That might be a thing we can think of it. It's just a
Yeah,
my thought, because
yeah,
I know.
that is the day even I realized that you need to be kind to the people who record the data.
Yeah.
Like they are also humans, and it can
Oh.
be like sometimes we get
Yeah.
very irritated sitting in front of the computer when you have a look at the data. Like suppose I am now working on developing this growth models. So you have a look at the canopy height data, and I get very irritated. Like the data is very inconsistent. You are not able to fit a model on it. But then when you realize like recording the canopy height for these cotton plants is not easy. You do not have any drones which will do it for you. I think they do it manually, and data has not been recorded the best way possible. But I sometimes feel that things can happen, things can go wrong. Like it's already a lot of labor on their part, and I think a lot of students are here like who do it regularly in this meeting, and like hats off to them. They have been doing it for years now.
Yeah.
Yeah,
Yeah, really appreciate that. Thank you.
Really appreciate.
yeah, perfect. Yeah, I think I'm sorry. I think I kind of sidetracked the conversation, but we can go ahead and start with other frameworks. Yeah.
Yeah, so the main frameworks for machine learning, the main language which has been promoted now is Python. And like I use Python, I know how to use R, but I no longer use R. C++ is used, but it's very rare. You do not have the libraries to put it on your data directly. Python, like 3 to 4 lines of coding, you can go on to run any machine learning model on your data set, which makes it very easy because all the algorithms have already been written in libraries. You just have to import those libraries. So by libraries, I mean like these are the code which has already been written down for you in packages. So by package is a collection of what do you say? It's an algorithm which has been pre-designed for you. So you just have to import them and run it on your dataset. So you need not do extensive coding to do that. You just search for that particular algorithm. You will get that and you just write 2 lines of code and you can run it. So Python does it for you very well. R does it for you, but then the interface of R is not the best, I would say, to visualize data or to, but R is a great language. R is used like for R is one of the first languages to be used for machine learning and data analysis. Python was not there then. So R is one of the pioneer in this, R SAS, but Python has like taken over the use of R and SAS nowadays because it is more friendlier to use, takes a little less amount of runtime, and the best part is it is easier to get online support for Python. Suppose your code goes wrong, any Python code like you can go get it in Stack Overflow or like many of these websites wherever. Like people will have the exactly same problem which you had, and they have the exactly same solution which may work for you. So that is the best thing. The online support in case of Python is great, which may not be in case of R and C++. C++ also it's fine, but not R and SAS. The Python community is really good. Really, it's a solid community. And these are the libraries on which I was talking about. So scikit-learn, PyTorch, TensorFlow, Keras. So scikit-learn is a library which has the machine learning algorithms already predefined in it. You just have to write 1 to 2 line of code, import scikit-learn as sklearn, and then use it. So you have to go and do your own homework and see how this scikit-learn thing can be used to run your machine learning algorithms on the dataset. But just remember this term, or like this scikit-learn thing can be used for a lot of machine learning algorithms. It goes on to habit within itself. and focus more on Keras. Keras has most of the deep learning algorithms in there. So any kind of neural networks can be written in a very simple way using Keras programming language. PyTorch and TensorFlow will be a bit sophisticated coding, so we'll not discuss more into it, but those are also deep learning frameworks. Keras is a simple deep learning framework and scikit-learn is a simple machine learning framework. We can go ahead and see on how that thing can be done, how students can go ahead and use it. So classic machine learning and its deep learning frameworks. So scikit-learn, it's nice end-to-end framework. It can be used for like data exploration. Like Pandas is also one of the libraries. It along with scikit-learn can be used to explore the structure in the data, then pre-processing the data. Pandas is another library which can be used to see the missing values. As I was talking with Dr. Sushil, you have a lot of missing values on what can be done with those missing values. You can go on to pre-process the data. Then you have to normalize the data before using it. Before feeding it into any machine learning algorithm, you have to normalize the data set. So what do you mean by normalization? So for each of these columns which you have, you go on to find out the mean. And you go on to subtract the mean from each of these values and divide it by the standard deviation of the entire column. So that is what normalization means. If you guys were not able to understand what I told, just remember you have to normalize the entire data set before feeding it into machine learning model. That is the rule of the thumb. You guys need to remember that. For normalization, you already have a set of code which is there. You just need to search for it and use it. Use it on your dataset, then feed it into the machine learning framework. Use it be it supervised learning, be it unsupervised learning, clustering, whatever. Normalization is a must. We cannot forget it because the main purpose of normalization is to bring down all of the data to one scale. So your data one may be 100, one may be 80, one may be 40, one may be 30, the values may be different. But when you normalize the data, all those values will fall between 0 and 1. So the variance between them becomes very less. And when you feed this type of data into any machine learning algorithm, it will go on to give you good values. That is the main purpose of normalization. And then training. So you have to train the machine learning algorithm with a particular set of data. And then this is testing. Then you have to test it with the other set of data, not the same data which you use for training. You should not do it. Like people have to do it in a lot of cases because they lack data. But at least in your case, when you have a lot of data, because 30,000 data points is not less, that is big data by all purpose. Like people can argue we need these many, that many. 30,000 is a good enough data set. There shouldn't be any excuse not to come up with a conclusion. I have worked with 27 data points for my master's and came up with a thesis and got it published also in a good enough journal. So there are ways to deal with it. And for my PhD also, I'm working with 147 observations. So those are really bad. Those are small data sets. This is fine. This is good enough. And then application on where you plan to use it. So for classic machine learning applications, you have scikit-learn. So that is it. This is the link for this. This is Keras. It's a high level framework for deep learning. So by high level, we do not mean it's difficult. By high level, you mean you do not go deep into it. You just mention how many layers you need, how many neurons you need. Just you mention them and they will do it for you. Very easy. It has a backend TensorFlow. You do not write any TensorFlow code. You just write it in Keras. And so by layer types, this is what it is dense, convolutional, pooling, embedding, recurrent, activation. So there are different types of layers which you go on to use in a deep neural network. Let me see if I have it in the next slide. I should have it. Yes. So I'll go over this slide first, then I'll again return back. OK. So this is a neural network. So what this thing is, this is a neuron. These are the different inputs. And then it goes like from these inputs, you go on to pass the data through an axon, and these axon terminals are the outputs. So that is the main inspiration behind a neural network. These are the inputs, x1, x2, x3, similar to xn. And these are the weights which are assigned to those neural networks. And this is a bias. And this is one particular output. And this is one particular output, y. So from output, like it means this one. So what is it? Like x1 w1 plus x2 w2 plus x3 w3 plus xn wn plus b. So that is what this equation means. So this is the basic structure of a neural network. So you go on to have these many input neurons, then pass it to another layer, then pass it to another layer, pass it to another layer, and then you go on to get the final output values. So what basically we go on to do is, when you pass it through these layers, it goes on to, you are more interested in finding out the final output in the end. But then for all these like W1, W2, which you saw in these slides, like W1, W2, those are called as weights. And initially those are assigned randomly. But that is what determines the correctness of the output, because the inputs do not change throughout the process. These W1, W2 will go on to change. When you go on to like proceed in the process, that will go on to change. And how that thing is done? That is done with the process of backpropagation. So the main thing is like you compare your output, algorithm's output with the desired output. If you have a large amount of error, you go on to this backpropagation algorithm will go on to reassign the weights. Then you again have a look at the final output, and this process will go on until you go on to achieve the best result. That is the main thing. If accuracy is good enough, stop. I'll not go like deep into it. That is what deep neural network means. And we can go on to proceed with it. So a brief overview. I do not want to overwhelm you guys with a lot of this information, but this is what it generally means. So then we'll talk about the data pipelines. So these are one of the main things which you need to, I have already mentioned this before, but you guys should be aware of this. First thing is data cleaning. Like you need to clean the data points. Like you have any outliers or invalid values, just remove them. If you have missing values, then impute them. Like there are many ways of imputing them. Take the mean, take the mode, take the median, fill in those values, and then proceed. It can mess up your model. Well, that is a risk, but then that is what data cleaning means. If you do not have a large amount of data points, then you have to think of other ways on how to reuse those data. That is the first step when it comes to design any machine learning model. Second thing is data transformation. I mentioned this earlier also. What scaling or normalization goes on to mean. So normalization is what, like subtracting the mean and dividing it by the standard deviation. Like the main purpose of normalization is to keep the values of the data, like of the predictors between 0 and 1, so that there is less variance in the data and you can feed it to a machine learning model. I have mentioned this before. So you guys should do some research on how to clean your data if it's required. If it's not required, it's fine. But data transformation is a very important thing. It should be kept in mind before running any machine learning model. So supervised learning. So this lecture will focus more on supervised learning. So first thing is select the model. So those models which I had given you a brief introduction about, like regression and the classification algorithms, you have to like go ahead and select a model which you plan to use. You can do a comparative study of those models. That depends on you. Then you have to train the model. After normalizing the data, you have to train those model with that data. Okay. So you have to have a bunch of like training data, which you will be using to determine your model parameters. So by model parameters, I mean that in case of any algorithm, machine learning algorithm, which you plan to use, by using training data, you go on to decide what the parameter of the model will be. So by parameter of the model, you mean that like in case of, let me talk about one of the algorithms like support vector machine. So you have a certain amount of penalty parameter or a gamma parameter. So in layman term, like there are certain amount of parameters which are there with every machine learning model. And with the help of this training data, you go on to determine the best, the optimal values of those parameters which should be used. And this validation data is there which you go on to use so that you do not overfit the model. So by overfitting and underfitting, like which has been explained in this diagram, I'll tell you like the detail about it. So by overfitting, you can go on to see that here there are two classes of data. This is a classic, like this is a classification problem. So all these dots, they belong to one class, and all this cross, they belong to another class. So you can go on to see that this particular boundary is a zigzag boundary, and this is able to distinguish between two classes. So very perfectly on the training data, all the cross are in one class and all the dots are in the other class. But when you go on to use a different test data on the machine learning, like the machine learning algorithm on the test data, this is not going to be the result. Because like we are overtraining it, we are overfitting. Like if a model is giving you 100% or 99% accuracy, that is not the best model to use. Somewhere around 85% to 90% would be one of the best approaches to go ahead and use, because this is a optimum model. Here you can go ahead and see like a couple of dots have been misclassified as one class and this cross has been misclassified as other class. But you can proceed with this. So this is the parameter, like this by model parameter, like this line, the parameter of this line is what we need to decide. So what should be the dimension of the line? So depending on the value of this line, we can go on to classify it as either like this category or that category. So we shouldn't search for the best model using our training data, because if you go for 100% accuracy, you will gonna get it wrong. So go for somewhere around 85 to 90% accuracy. That is gonna give you the best results. And a classic case of underfitting is like it is poor on the training data itself. Like it is not able to even work like function efficiently on the training data. That is what it means. For test model, like you have a different set of model to test, like the set of data to test your model. And depending on the testing data, you go on to finally record the score of the model. And then the production is like you go on to give a certain set of input and go on to predict your output. It can be any input and any output. Once your model is ready, select the best model. So this is what.
Sam, I'm having one question. Okay. So like, let's think about it. Like, suppose I'm having 100 data points and I have splitted my training and testing data set, like the data set as 70 and 30. And I have trained my model with the 70% data. And I'm planning to predict, like, prediction done on the 30% of my testing data. So like which point, I should know like my model is underfitting or overfitting, and how we are gonna identify that okay, my model got underfitted at this point. So
So,
yeah.
so based on your 70% split on the training data, If you are not able to get good results, that means your data is underfitted. And if you are able to get 99% accuracy, that means it is overfitted. Keep the testing data separate. Just depending on your training data, training accuracy, you can go ahead and determine whether you are overfitting your model or underfitting your model. If you
So
are
how
getting very,
Okay,
yeah.
so how about if I think about like this way, like okay, my data is excellent. My data is, very good data I got, and that's why my model is predicting 99%. And mostly people used to get happy when they see, the model prediction is 99%. It's really excellent. So like, is there any other parameter like I can just apply and see, okay, so let's even though the model is predicting 99%. So I need to see like, these parameters to make sure my model is overfitting.
Go
Is-
ahead with the test data then and see how your model is performing on the test data. If it is giving 99% accuracy on the test data, perfect. Then like you should be happy. But if it is giving you 60% accuracy on your test data, 99% accuracy on your training data, then it is overfit.
okay,
So
thank you.
there shouldn't be a lot of variance between the training accuracy and the testing accuracy,
So
basically.
do you take consideration of the like RMSE value, R square value too for the, like even the model is predicting 99%. So like do we have to look into those parameters as well? The
So
R
RMSE
square.
is like root mean square error.
Yeah.
So RMSE is like the basic, that is the main like yardstick to determine the accuracy of the model. So
Okay.
root mean square error. It's yeah. So you will have the RMSE there. So if you
Okay.
definitely.
Okay. Thank you.
Thank you. So in conclusion, we have reached the end of the talk today. So you learned about classification algorithms, some regression algorithms, some clustering algorithms, some predefined software libraries which can be used, like scikit-learn, pandas, which I discussed, Keras, and some deep learning frameworks like Keras, TensorFlow. So Keras is something which I would encourage you to use. Like if you plan to use deep learning, if you plan to use machine learning, you have a lot in pandas and scikit-learn. Thank you.
Yeah, I
Any
think that.
questions?
Yeah, any questions from student? I think that was a really good overview on machine learning. I personally took a lot of notes. I think that there were a lot of things that were of interest to me. Any questions from the students? Maybe, yeah, if you are wondering, okay, what would you do with your data set? Maybe you now at this point you should know what are the variables you are working with, what are some of the outcome variables, what are the variables of interest, and maybe I think this would be a good time. Maybe share with us what do you think would be a good approach, or what do you think about your data set? Can we use machine learning on that? And maybe I think this would be a good discussion. Like Sam said, I think you would learn more if you apply that to your own data set, or not only apply, but think about it, how you can use it on your data set, right? I think let's start with questions if there's
Yes,
any
sir.
questions, and then we can go and do the discussion on that.
So like anyone from the plant side?
Maybe we need to call out the names.
And I gave an overview of the animal data set, but like I'd like to know, right? Like, so what are the variables you are working with on the plant side, and what are some of the variables of interest, and if you can use this kind of framework on your evaluations. Just yeah, give us an overview on what kind of data set you are working with. I think that would be the starting point.
Anyone?
Uh, okay, so probably like I can talk about a little bit about the plant science thing because we are working on it. Uh, so mostly with the guidance of Dr. Bhandari. So me and Sam, we are working on the machine learning prediction part, as well as we are trying to implement a prediction application as well. So what we have in the plant, like canopy cover, canopy height, and excess green index. So
So
those are
are they using the same plant dataset? I don't think so. So they're using the same?
they're using
Okay.
the same data set. Yeah. So we have all those features like every 2 weeks, our plant science students, they used to go to the field, and they used to fly drones, and they used to get the pictures of the field, and then they used to process those datas through orthomosaics. So the plant science people know more better than me. I'm just a part of it, and then out of it we used to get the data points, and the yield also. So how much the yield, and they have a growth period. They used to keep a measurement of the growth period, how the plant growth happens, and based of it, so we are trying to predict the yield of the particular season, like if this is the all the parameters, like by considering the canopy cover, canopy height, and all these parameters, we are trying to predict the yield as well as the plant growth. So like we are trying to now also trying to predict, so before 2 weeks, what could be the plant height or plant the canopy cover. So those are the certain things we are working on it right now. Yeah, so from my end, yeah.
Your predictor variables would be kind of temperature, and what would be your X variables? Like, yes, your plant height, everything would be your Y variable. What would be your X variables?
Those are the X variables.
Those are the X variables.
Okay.
So Y will be the yield of the crop.
Oh, okay.
Yeah.
So how many data points do they have?
So I think the folder has the data from 2021, which should be around 200 or 250. Just kind of one-sided data points, but that should be enough to just to learn some of the basics on playing around if they want.
Yes, definitely. So Dr. Sushil has a huge data set, like 30,000 data points for the animal data. So anyone who is working on the animal data, any of the students who has explored the data until now?
Is the animal science leader?
Yeah, and I can just give us an overview. I think I gave some insights on how we can use. I don't know if we have Jack, and I think Anna was there this
Is there
morning.
anyone like who has done it? Because like we are already at the end of summer and we need to like see on what students have done until now. They've explored the data.
They are still kind of trying to get everything in MySQL, I guess. I think that's where they are struggling a lot, and that's the major portion as well. So I think our analysis was not a big component of the project. So I think they are learning to build the data set in MySQL. I think they're still doing it, but I think within that as well, if anyone, like maybe Jack, if you can give us some insights on how do you think this could be used, or what kind of predictor variables you can use to predict, I think that would be enough, I think, for now, sufficient for now.
Okay, yeah. I mean, I am an animal science student. I'm trying to find the notes that we took on this, but we have tried to take some observations based on the data, or we're trying to make connections. But that'll be a secondary thing, obviously, after we get it into MySQL. But we're thinking we can use this tool to relate, days of milk related to milk yield, or milk yield relating to grazing. Of course, on our data set, you measure grazing other than a binary value, or it doesn't. So that could be a little bit more complicated, but that's as far as we can get on that. We've also got hoof ailment related to movement. I think Dr. Sushil, you were talking about that earlier. You said you were doing a little bit of research on that yourself. So I think it's kind of cool that my group thought of that, but and that we kind of coincided in that accidentally, but that's where we're at on that. There are different, as for our variables, we obviously have our primary variables being cow ID. I think we've got a set of, 200 or so cows, and it repeats for 300 days. So you get data on all those cows for 300 days or so. But there's some movement related variables. There's some illness and milk yield related variables, different conditions going on, hoof trims, that sort of thing. So that's what we're looking at on our data set.
And Jack, to complement the similarity in the data set is that you have 200 cows, and in the plant science data we have 200 plots basically, and then we are collecting data almost every week. That makes, if we put it in the vertical space, then that makes around maybe 200 multiplied by 20 times. It will be somewhere around like 2,000 data points.
Yeah.
In total. But the idea would be to just put together the dependent variables and try to link everything with the yield or something else in the animal science, basically.
Right, and so we're trying to figure out what the explanatory variables would be versus the response variables, and so that will be later on in the project. First, we need to nail down our database and our data set, and kind of go from there. We'll work on visualizing it once we do that.
So I'm having one question. So what is, like, where are we? Like, what is the issue? I thought like we are good at the database side. I thought like we're able to upload the data set. So are you guys, if you're finding difficulty, I can just show you a simple demo how you can upload the entire data set into the MySQL. Dr. Bhandari and I worked on it maybe last week. So I worked with Dr. Bhandari and we figured out the way. So if you guys are still finding some issues, just I can give you a demo. So
yeah, so Tapas, I think what I suggested my group this morning, I had a meeting with them to explain some variables, and I think that's the immediate need. So that's what the group will be needing to do next, is either work with you or work with Jose, whoever is kind of more knowledgeable about it. They need to work with you to upload everything into MySQL and make those connections between like primary variable and what are the other variables, and create multiple tables, link those tables together. So I think that's going to be their task next. Is I don't think like a demo. Yes, I think that would help, but let's maybe if you can find an hour or something to work with them and tell them, okay, this is the way to go. I think that's where they will need a lot of help, like either like Tapas or like Jose, whoever is free or whoever is around. I think that's going to be very helpful for them.
so what I would suggest here, let's do a, like let's not show them the actual data set how to do it. So let them, I wanted those guys to learn it how to do it. It is just the exact step how it is just, it won't take much time. Just as like I can create a small Excel or CSV file, and where I can show, okay, this is the way how the data can be imported to a SQL table or SQL thing. So I wanted these guys to be work a little bit. If they are not finding difficulty later point, we can help them. But like that's how maybe they will learn a little bit more about it. So that's the thing I can suggest. What best suit for them? I'm fine.
Yeah, let's wait if they can figure out, and maybe that's where they will kind of reach out and see. And I think I really like your approach. I think that's hands-off approach. It's where you learn. You don't learn unless you do it yourself on your computer.
Right.
You don't learn unless you get a data set uploaded into MySQL. If you do the work for them, I think you'll not learn. So that's really a good approach. I really like that hands-off approach. But yeah, let's let them figure out the MySQL thing. Let them work for some time. If not, maybe like I said, both of the groups reach out to Tapas or Jose and maybe work with them and get that done. Next week we have a work week, so we don't have a presentation schedule for next week. So I would ask, let's say, figure out everything by next week. If not, maybe meet with like Tapas or Jose next week to go and get the demo for you. And by the time we meet week after that, let's all groups, let's have something in place and have a good database so that you all can start working on visualizations and stuff after that. We'll have only 1 week after that, so let's get it finalized. So next week is a work week. You all kind of work on your own, work with Tapas, work with Jose, get that thing done. And by the time we meet next time, let's have a database in place, everything set up, and maybe clean something, clean up the database, and we'll work on that visualizing piece after that. Right? Any other questions, concern? Okay, I think if not, we can end the session here. And thanks someone. I think that was really a good overview. I really like. I'll be honest with you. I wrote a lot of points here, like for my review as well. And we'll upload the slides on the Teams page as well. Those are very helpful slides as well. So those will be there. And in the meantime, like whenever you are working, feel free to reach out. I think I said, like, I was with the group this morning helping them. Dr. Bhandari would be willing to help the other teams as well. So feel free to reach out and work with us and go from there, right?
Yeah, sure. I think that sounds like a plan. Maybe within next 2 weeks, let's create something in the database so that during this process, you'll learn a lot. And you can reach out to me as well anytime, send me an email. I can jump in your group meeting, especially the plant science group, and then discuss the variables or whatever you need from my side. Okay.
Yeah, and I think Dr. Lucy is here as well. I think on one of the groups they reached out to Dr. Lucy for help. I think they thought I heard that was a very helpful session. So utilize us. Of course, we need to work with our schedule and things going on with summer, but let's get everything done by let's say use the work time next week, and by the time we meet the week after that, let's have something in place so that we can talk about it and then discuss about it. Okay. Okay, I think we'll end the session here. Thank you all very much and have a great week. And see you.
Thank you so much. Thank you all. It does seems Dr. Bhandari moved to a new place. I can see.
I'm relocated to College Station now.
Yeah, he will be here.
Oh, that's really nice to see in a new place. I thought because Dr. Bhandari office used to be next to our office, but seems it's really nice to see a new place.
Enjoy
Thank
the freedom, guys.
Yeah. Enjoy the freedom when you can. Right, so.
Yeah, thanks, Sam, for the presentation. It's great. Thank you.
Thank you.
Thank you.
Thank you,
so
Dr.
much, sir.
Lucy. See you.
See you. Bye.